Hello. So today we are discussing the solutions of the Introduction to Logic major examination. Now, as you can see that this was the question paper of the major examination, and we have received around 338 responses. And we asked you to fill the name as well as the entry number. These were certain things which we required, as well as your email ID. Now, many of you may have not written the right email ID because there were some spelling mistakes over there because somebody has not written the dot in between or something like that. So when we will be releasing these codes, maybe it will not reach you. But do not worry if it has not reached you or something. So you can always email us back and we will send you the score at the right email ID. So that is not going to be a problem. Now let us come to the objective questions. As you can see that there were a lot of objective questions, around 20 marks objective questions. So what were the things which we required? Now all these questions, if I may tell you, were very, very conceptual. There is no need to solve them much. If your concepts are proper, if your concepts are clear, then I'm pretty sure that you found it very interesting as well as very intriguing. But on the other hand, if your concepts are not right and you have to solve it, so it will take away a lot of time. So that is the thing. Now, in this question, we were asking that which of these is not having an identical when pairs diagram. Now, the first thing which you should understand is that in when pairs diagrams, the E proposition as well as the I proposition, they will always be having the same kind of images, irrespective of the fact that you are taking it in the first figure or the second figure or the third figure. On the other hand, the A proposition as well as the O proposition, they do not have that kind of isomorphic images. So if you see in this question, you can see that AAA was one of the options. In other one like EI or II or EE or IE or EE or II, all of them will be having isomorphic images, so it will be having an identical diagram. The one which will not be having an identical diagram will be AAA, and as you might be aware of that, AAA is valid in the first figure, but it is not valid in any other figure. So it precisely is the case because the diagrams are different. So the answer was A over here, that is AAA. If you see that this is the right answer, triple A. Okay, now let us go to the next question. Only citizens can vote and all voters are citizens. If you see, only citizens can vote and all voters are citizens are nothing but equivalent expressions, right? So the answer of this was this one, equivalent. Fine. Then which term is distributed in a statement? It is not the case that some students are lazy. Now, if you know that it is not the case that some students are lazy is a negation of an I proposition. So when you go for a negation of an I proposition, it will become an E proposition. And you know that in E proposition, both the terms are distributed. So you can see that both of the above will be the answer. Now, in the next question, if the truth table of P hashtag Q is conventionally shown as all F, that means that it is a contradiction, then P hashtag Q can be expressed as. And if you see none of the options available over here will actually give you a contradiction. So irrespective of the fact that you work out, but since you know the truth table of P dot Q, so a negation on that will not make a contradiction. Similarly, you know all these truth tables you have gone through in your course. So you can see that none of these will actually make a contradiction. So the answer was none of the above, as you can see. Now, in the next question, a valid standard form categorical syllogism, in a valid standard form categorical syllogism, no conclusion follows from a particular major and a negative minor premise. So yes, it was true, as you can see, because if you have a particular major and a negative minor, so no solution or no conclusion follows from it. You can always solve it, or you can just see it, because since you know the concepts and all these things, so I'm pretty sure that you could have solved this question as well. Now, next question, in a traditional square of opposition, if the superaltern is false. Now, superalterns are the universal propositions, right? Then what about the subaltern? Now, the subaltern is false? No, it is not the case. There is nothing which you can determine from here. So the answer was false, because if suppose somebody is saying that subaltern is also false, so it is a false statement. Why? Because the subaltern can be true or can be false as well, right? So the best thing is that if the statement is written like subaltern is also false, so you should say false. This statement is false. If I would have written over here that if the superaltern is false, then the subaltern is, and I have put a bracket over here, or I have put a dash over here, then you should have filled cannot be determined. Now, next question, tomatoes are fruits. Now, it means that all tomatoes are fruits, right? So it is what kind of proposition? It is a true proposition. It is a false proposition. There is a big argument on this, whether tomatoes are fruits or tomatoes are vegetables. But what you can safely say is that it is a universal proposition, right? Because tomatoes are fruits will be symbolized as all tomatoes are fruits, right? So safely, this is the thing. True and false can be a big argument. So the answer was universal affirmative. Next question, material equivalence of two propositions, say P and Q is logically equivalent to the negation of an exclusive disjunction. So if you know the exclusive disjunction truth table, so it is false, true, true, false. Now, false, true, true, false, if you go for the negation of that, it will make it true, false, false, true, which is exactly the truth table of a material equivalence. So the answer was yes, true. It is true. Next question, if P1, P2, P3 up to Pn are premises and C is the conclusion of an invalid argument, then P1, P2, P3 up to Pn, and there is an additional premise that is Po as premises and C as the conclusion will be N. Now, it can go anything. Because if it is an invalid argument, so adding an extra premise can change its validity or invalidity, but we have no idea about it, right? So it can be either valid or invalid. So the answer was valid or invalid. Next question, if P1, P2, P3 up to Pn and are the premises and C is the conclusion of a sound argument. Now, sound arguments are valid arguments with true premises, right? Then P1, P2, P3 up to Pn and Po as premises and C as the conclusion will be N. Now, I do not know what is the value of PO, right? So PO can be true, PO can be false, but irrespective of the fact, it will always stay as a valid argument. So the answer of this question will be that it is valid. Next question, adding an extra premise to an inductive argument. Now, you know what are inductive arguments. They are strong or weak, right? So can further either strengthen or weaken it, right? Because again, for inductive arguments, there is no concept of validity or invalidity. But if it is an inductive argument and you add another premise, so it can change its strength, right? So it can make it either strengthen or it can weaken the argument. So the answer was this one. Next, in deductive logic, some arguments are more valid, whereas some are less valid. This is an absolutely false statement, precisely because in deductive logic, you have arguments which are valid or invalid. There is no less or more or something like that. In inductive arguments, there are very strong arguments, weak arguments, very weak arguments, and something like that. But in deductive logic, it is not happening. So the answer was false. Next question. They are bidirectional. That is, the ratiocinator can move from top to bottom or left to right and vice versa. The above statement is regarding. Now, what is bidirectional? Bidirectional precisely means that you can move from left to right as well as from right to left, or you can move from top to bottom as well as from bottom to top. So this is true for rules of replacements, right? So the answer was rules of replacement. It was not for rules of inference, because in rules of inference, they are valid arguments, which means that you can move from top to bottom, but you cannot move from bottom to top, right? So it was rules of replacement. Now, in a valid argument, if the premises are true, then the conclusion must be true. The above statement is regarding. Now, the catch was that syllogistic arguments are also deductive arguments, right? So the answer was both deductive and syllogistic arguments here, right? Okay. If in a deductive argument, the conclusion is a tautology, then the method of deduction permits us to prove the argument is valid, even though it has no premise. And this is true about tautologies, because tautologies are arguments in itself. This is something which we have always talked about. And in fact, if you understand the meaning of validity, so it very clearly says that what is a valid argument? That the conjunction of the premises implying the conclusion must be a tautology. Now, the conjunction of the premises implying the conclusion is a tautology in itself becomes a valid argument. So a tautology in itself will become a valid argument as well. And therefore, there is no need for having premises. Similarly, as you know that in our course also, we have proof for tautologies, right? So when we are proving tautologies, it also uses the natural deduction method, and that itself also says that we do not need premises, in fact, to prove that something is a tautology. The next question, the terms man, men, or mortal, Socrates have no essential occurrence in the argument. All men are mortal. Socrates is a man, therefore Socrates is mortal. So it precisely says that deductive arguments are more structural by nature. They have a syntactic understanding, right? So the syntax is important. Even if you change men with goats or Socrates with, say, Sunil, it will remain the same, right? So this was a true statement. Next question. In a valid standard form categorical syllogism, a particular conclusion follows from two particular premises. You know that no conclusion follows from two particular premises. So the answer was false. Next question. Some women are not strong persons because all mothers are strong persons, but some women are not mothers. The conclusion in the above argument is, so you have to find the conclusion. And if you see here that some women are not strong persons, and after that you find because. So after because, these two propositions, because and but, they are making these two as premises. There was no conclusion indicator, but since there are premise indicators, so default way this will become the conclusion. Some women are not strong persons. So the answer was some women are not strong persons. Next question. In a valid standard form categorical syllogism, a universal affirmative conclusion necessarily implies that both the premises are universal affirmative. It is true, because a universal affirmative conclusion can come from a universal affirmative premises only. And if you see, there is only one case, that is AAA. Which is valid in the first figure, and that is the only place where you will find that a universal affirmative conclusion comes out, right? So it was a true thing. Next, in a traditional square of opposition, the superaltern is always an affirmative proposition. So you might be aware of that, what are superalterns and what are subalterns. So superalterns are basically universal propositions. They are not affirmative propositions, right? So here the answer was false, as you can see. Okay, now the next question was that construct a truth table to show that the negation of a conjunction of four statements is logically equivalent to the disjunction of their negations. So if you see P, Q, R, and S, so there will be a 16 row column table, and we have to just put the values. And if you see, the value of P, Q, R, S will be true, and rest of them will be false. So the negation of all this thing will be false, and rest of them will be true. And if you compute the value of negation P, wedge negation Q, wedge negation of R, wedge negation of S, so it will also come out exactly the same way. So you can very well understand that these two were equivalent expressions, and the truth table of these will come out to be like this. Next question about symbolizations. Let us discuss the symbolization questions. The first question was, among birds, kiwis, ostriches, emus, cassowaries, and penguins do not fly. So you have to make like this, bx, where x is a bird, then kx, x is a kiwi, and all these things you have made. And then the symbolization will be for all x, bx implies kx, wedge ox, wedge ex, wedge cx, wedge px, precisely because that you cannot put ands over here as, say, conjunctions. Rather than this is an or kind of function, as we have already discussed in the course, implies negation of fx. That means that it cannot fly. Now, the thing is that this is an exportation kind of thing. So even if you put bx dot kx, wedge ox, wedge ex, wedge cx, wedge px in one bracket, and then you put an implication and say negation of fx, so that will also be the right answer, because the exported understanding of this is also going to be the right answer. The next question was, neither demons nor ghost exist. So if x is a demon for dx and in gx, x is a ghost, so you can see the symbolization over here. Next question, yellow bananas and red apples are ripe and sweet. So you need to take yx as x is yellow, bx is x as banana, and all these things. And then if you see the symbolization for all x, yx dot bx wedge rx dot ax implies tx dot sx. So here the catch was that you should not use rx for ripe as well. You have to use something else. Or if you have used rx, for red, similarly, if you have used it here, or say you have changed it here, so you can put it rx over here. So these small changes you need to make it whenever you are symbolizing, and that is something which is very clear to you people. Now next question was, Freud was not a politician. Now this is a singular statement, and you do not need quantifications or quantifiers over here, but the quantification theory will say that you have to put it like f, or say pf for Freud is a politician, and then you have to put a negation over here. Now, next question, single women are decorous if they are chaperoned or have paramours. So Sx for X is single, then Wx for X is woman, and all these things you have put. Now, again, you can see that Sx dot Wx implies Cx, wedge Px implies Dx. This is going to be the symbolization. And if you put the exported understanding of this thing, so it will be Sx dot Wx dot Cx wedge Px implies Dx. So even that symbolization will work. So you need to take care of the brackets. So those things were there. The next question was, only reptiles are snakes and lizards. So Rx is X is reptile, then Sx is snake, then Lx is lizard, and you have the symbolization over here. So these were quite simple questions. Now let us come to the fallacy questions. In the fallacy questions, the question was that find the fallacy of ambiguity in the given argument and state your justification for the same. The statement was like this: Harry loves Sally, thus Harry can never kill Sally. Harry loves chicken, thus Harry can never kill the chicken. Now, the above argument commits the fallacy of equivocation or amphiboly, in whatever way you will like to take it, because either it is the word, phrase, or something. So even if you are writing equivocation or if you are writing amphiboly, we are providing marks for that. It is precisely because the speaker of the above argument is not distinguishing the word or phrase loves as someone loves someone and someone loves to eat something, because the word love has quite a different denotation in two sentences above. So where killing and consumption of the same is involved. So you understand that the thing is that loves does not only mean that you love a person. Love something also means that you can eat something, right? So if you are eating something, so maybe you will be killing it as well, right? And even vegetables are killed, so forget about animals. So those understandings are there. So the confusion was related to the word or the phrase, and therefore whether you are writing equivocation or amphiboly, both will be awarded marks. Next question. Find the fallacy of relevance in the given argument and state your justification for the same. You cannot drop Virat Kohli from the team just because his present form is gloomy. How can you forget what a brilliant batsman he is? Now, what the speaker is trying to incite some kind of emotions, right? Now, the above argument commits the fallacy of appeal to emotion. Here, the speaker is asking us to believe and incite an emotion, usually melancholic, or feeling that one should not desert someone just because his present form is bad. Rather, we should glorify his class or form forever. Does not matter whether right now he is in fine touch or not. We should always be a fan rather than analytical or critical about somebody. Now, this whole argument, if you see the above argument, is a fan argument, right? It is coming from a fan understanding. It is not coming from a critical or from an analytical understanding. You can be a fan of somebody and stuff like that, but then if somebody's form is not good enough, so he or she is dropped from the team, right? So that is the understanding. But we need to understand that what we are trying to do is to create an emotional or a melancholic understanding that look how pity it will be for that person because he has won so many laurels for our country, right? So that kind of thing. Next question is also about fallacy. I am taking over here. I have jumbled the questions a little bit. Explain the difference between fallacies of relevance and fallacies of defective induction with the help of examples. Can an informal fallacy be valid? State your reason. So this question is something where everybody has to be very, very different. The above questions, there can be people who will be writing the same kind of answers and so on. But in this question, it has to be absolutely different. Now, Fallacies of relevance share a typical characteristic. The argument in which they occur have logically irrelevant premises to the conclusion. So you know the fallacies of relevance precisely means that the premises and conclusion are irrelevant to each other. Let us take the following example. When we judge a person's character in place of the merit of the argument, we commit the fallacy of ad hominem. So we know that it is against the person, right? So against the person are fallacies, which are fallacies of relevance. We also call it ad hominem. And in that, what happens is that we are not arguing against the argument. Right? We are not considering the argument, rather than we are judging the character of a person, that, oh, how can you say this? How can you say that? You yourself have been like this and that, right? So those kind of things are basically ad hominem argument. Next, when a conclusion has been made based on weak premises or not justified by sufficient or unbiased evidence, fallacies of defective induction are committed. For example, since there is insufficient evidence to prove that he has committed the crime, he is confirmed non-guilty by the court of law. So this is happening everywhere, and we have discussed it also in fallacies of defective induction, that what are the things which are happening. So what is this fallacy? I will just like to know from you guys that what was this kind of fallacy. If you understand, it is basically fallacy of ignorance, right? Okay. Yes, an informal fallacy can be valid. Now this is the question, or this is the answer of this question, that question which was asked over here, that can an informal fallacy be valid? Now the answer is yes, an informal fallacy can be valid. This might be a shocker for a lot of students, right? Why? Circular arguments or begging the question do not make premise conclusion distinction. Thus, they are fallacies in informal discourses or inductive logic. However, in deductive logic, we can definitely and decisively conclude a statement P from the premise P, and it will be a tautology, right? And there is absolutely no problem, as it is governed by the rule of tautology. So from P, you can always derive P in deductive arguments, but in inductive arguments, if you are doing it, so people will call it like it is a circular argument, right? Or it is begging the question. So an informal fallacy can be a valid argument. And this is a very intriguing and interesting thing which you should be knowing. Something like this was also discussed in the class, but maybe many of you have not followed. Now, let us come to the proofs of this question paper. So the proof was, and this is the proofs which I have taken from Kevin Sombra, who is a student in civil engineering this year, and he has done the paper very nice. I guess so. I have seen his paper. Mostly things are quite okay. So I have borrowed the solution from his paper only, and you can see the solution over here. So negation of P, wedge negation of Q, you have to prove as equivalent to P implies negation of Q. So this was the solution, something which we use SCP, and you can see the solution. Many of you have done it, so I'm not getting into the details. But again, if you are not writing the rules over here or not properly, say, putting the closure and all these things, so some marks can be deducted, or else many of you have got it right. Let us come to the next question. The next question was, prove the following valid or invalid using quantification theory and its required restrictions, if any. Now, if you see this question looks very intriguing, very interesting. In fact, the solution which we have provided in the last video, maybe, and you have watched it, we were also confused with this understanding that it is valid, but it is actually not valid, precisely because if you use any of the propositions in the particular propositions and you go on to instantiate it, the first thing is that you have to instantiate these ones before the universal instantiations. But if you go on to instantiate and after that you solve it, so you will not be able to universally generalize it, right? Because if you have gone for a particular instantiation or an existential instantiation, so you will not be using that value for universal generalization. So that was the restriction, or that was the problem. And because of that, you will see that even if it can be proved, ZA implies RA can come, and after that you can go on for universal generalization for all X, ZX implies RX. But then it is not possible. It is, we have the restriction that from an EI you cannot go for a UG. So that understanding is always there. So we rethought on this question, and let us so we rethought on this question and thought that, okay, let us try to prove it invalid. Whether we can prove it invalid. If we can prove it invalid, definitely then there is no way in which it will be valid. So here is the way in which you can prove this question to be invalid. Now, as we know that for proving this invalidity, we will be opening it up, and we are opening it up with 3 variables rather than 2, because sometimes there are problems with 2 variables. With 2 variables, the question is not possible. 1 variable, the question is not possible, but these questions are possible with 3 variables for sure. So we, on the safer side, opened it with 3 variables. So as you can see that we have opened it with 3 variables, and we have used an AND function for a universal proposition and a wedge function for a particular proposition as it was introduced or as the rules go. And so these are the premises and this is the conclusion. Now, the idea of proving invalidity is that you have to make the premises true and the conclusion false. So how we start with? We start with whether we can prove or whether we can show that the conclusion is false. So first and foremost is that we have to prove the conclusion false. Now, as you can see that the conclusion is an AND function. So in AND function, any of these, if it is false, then the whole function will become false. Now, one way of making it false is that we can make all of them false, and by virtue of that, it will become false, or 2 of them false, and again, it will become false, or even 1 of them will be false, so it will become false. Now, the trick is that you should keep the true statements more with you, because you have to go on to make the premises true first. So what we do is that in conclusion, what we are doing is that we are taking this part, ZC implies RC, and we will make it false. Rest of these statements we can make it true. So it will help us in the above propositions. So when we are trying to make ZC implies RC as false, so we know that ZC has to be true and RC has to be false. So we have put ZC as true, and as you can see, RC is false. Here you can see that RC is false. However, in this place, ZC is true. So this will make this part false. So once this will make this part false, it precisely will mean that everything will become false. Now we are keeping the rest of the values in our hand so that we can keep it. Now you can see that RC is false, right? So RC is false, and if you go to the first statement, you can see again it is an AND function and all of them have to be true. So if RC is false, then it is necessary that PC.QC has to be false as well, because or else if PC.QC is true, then this will become false, and because of this, the whole of the function will become false. So that will create problems for us. So since RC is false, we have to make PC.QC as false as well. So what we are doing is that we are making PC as false. However, we are keeping QC as true only. Right? So again, with one function, we are doing it. So PC.QC will become false, and after that, RC will become false as well. So false implies false will be true. So this part will be true. And for rest of them, like PB, because all of them have to be true as well. So you can see that PA and QA are both true, and RA is also true. Similarly, PB and QB, if you see PB and QB, both are true, and RB is also true. So this line is done, right? So this whole line will become true. So our first hurdle is taken care of. Now let us come to the second line. Again, second line, you can see that the important thing is that whether QA, QB, QC. Now you can see that QA, QB, QC all are true. So QA is true, QB is true, and QC is true. So irrespective of the fact, whatever value this RC wedge TC or this RB wedge TB or this RA wedge TA will come out to be, but since QA, QB, and QC are true, so this whole function will be true. So we have made both these lines true. Now the next is our third line, that is PA.QA, PB. Now the advantage with these two lines is that they are connected by wedge functions. So any one of them is true, so it is going to do our purpose or serve our purpose. So you can see PA.QA, PA is true as well as QA is true. So this whole line will be true. Similarly, if you come to the next line, that is ZA.TA wedge this, and again you can see that it is a wedge function. So let us see, we have ZA as true and TA is also true. So this part will become true. So the rest of the things will become true. So This is one of the substitution instances of this question. There can be more, because as you can see that there are degrees of freedom, and because of degrees of freedom, you can have more values with that. But if one of these things have been taken care of, so you can already and very easily prove that this function is going to be, the whole of the premises will be true. However, the conclusion is false. And by the definition of validity, if the premises are true and the conclusion is false, then definitely the argument is going to be invalid. So this was the solution of the second question, which was related to prove the validity or invalidity. As you can see above here, prove the following valid or invalid using quantification theory and its required restrictions, if any. So this was the solution which I could provide to you, but there can be other kind of solutions as well. Precisely with the descriptive questions, there can be people who have different kind of solutions, or they have given different kind of examples, or the symbolization scheme has changed and something like that. So we will go for very rationalized marking. But if there are errors or there are some problems in these solutions, so definitely some marks will be also deducted. So I think that we have clarified the doubts, and once the marks or the score will be released, we will have a meet, so that if there are any clarifications required, so we will be also going for it. Thank you very much for watching.